Hello! The law of sines is used to solve oblique triangles, and these are triangles that don't have a right angle. In this figure, we have an oblique triangle with sides A, B, and C. Opposite of side A, we have angle A, opposite of side B, angle B, and opposite of side C, angle C. So each side is represented by a lowercase, and each angle by an uppercase. Then the law of sines is A over sine of A equals B over sine of B equals C over sine of C, or sine of A over A equals sine of B over B equals sine of C over C. To understand this law, I will show you two proofs. So let's start with proof 1. For this, from vertex C, we will draw a perpendicular to the opposite side. Then this will be point D and the height h sub 1. And now we have two right triangles. One of them is ACD and the other one BCD. In the triangle ACD, we will use the sine function to write that sine of angle A equals the opposite side h sub 1 divided by hypotenuse B. So again, we will write that sine of angle A equals h sub 1 divided by B. Then if we solve this for h sub 1, we will have that h sub 1 equals B times sine of angle A. Now in the triangle BCD, we will write that sine of angle B equals the opposite side h sub 1 divided by hypotenuse A. So again, sine of angle B equals h sub 1 over A. Then if we solve this for h sub 1, we will have h sub 1 equals A sine of angle B. And now, because both these expressions represent h sub 1, then we can write that B sine of angle A equals A sine of angle B. Now, in the next step, we will divide both sides of this equation by sine of A, sine of B. So I will divide the left side by sine of A, sine of B, and I will do the same to the right. Sine of A, sine of B. Then on the left side, sine of A will cancel, and on the right side, sine of B will cancel. And now we have B over sine of B equals A over sine of A. And these are two of the ratios that we see in the law of sines. Now let's draw another perpendicular from either vertex A or vertex B. I will draw a perpendicular from A to the opposite side. Then I will call this point E and the height h sub 2. And now we have two more right triangles. One of them is ABE and the other one ACE. In the triangle ABE, we will use the law of sines to write that sine of angle B equals the opposite side h sub 2 divided by hypotenuse C. So we will write that sine of angle B equals h sub 2 divided by C. Then we will solve for h sub 2, and h sub 2 equals C sine of angle B. Now in the triangle ACE, sine of angle C equals the opposite side h sub 2 divided by hypotenuse B. So again, sine of angle C equals h sub 2 divided by B. Then h sub 2 equals B sine of angle C. And now, because both these expressions represent h sub 2, then we will write that C sine of angle B equals B sine of angle C. Now we will divide both sides of this equation by sine of B, sine of C. Then on the left side we will cancel sine of B, and on the right side we will cancel sine of C. And now we have C over sine of C equals B over sine of B. And now if B over sine of B equals A over sine of A, and B over sine of B is also C over sine of C, then we can write that A over sine of A equals B over sine of B equals C over sine of C. Now, what if the oblique triangle is an obtuse triangle like this one? Then we draw a perpendicular from vertex C to the extension of side C, and let this point be point D and the height h sub 1. Then again we have formed two right triangles. One of them is BCD and the other one ACD. Then in the triangle ACD, sine of angle A is h sub 1 divided by B. So we will write that sine of angle A equals h sub 1 over B. Then if we solve this for h sub 1, we will have h sub 1 equals B sine of angle A. Now let's talk about the triangle BCD. If this is angle B, then this angle is 180 degrees minus B. And this is because these two angles are supplementary. So then, in this triangle, we can write that sine of 180 degrees minus B equals h sub 1 divided by A. So again, sine of 180 degrees minus B equals h sub 1 over A. Now, what we need to know here is that the sine of supplementary angles is equal. For example, the angles of 120 degrees and 60 degrees are supplementary. Then we can write that sine of 120 degrees equals sine of 60 degrees. And we can also see from the unit circle that sine of 60 degrees is square root of 3 over 2, and sine of 120 degrees is also square root of 3 over 2. So then, in this equation, we can replace 180 degrees minus B with B. Then we will have sine of B equals h sub 1 over A. Then we will solve for h sub 1, and h sub 1 equals A sine of B. And now, if both these expressions represent h sub 1, then we can make them equal. We can write that B sine of angle A equals A sine of angle B. Then in the next step we will divide both sides by sine of A, sine of B. Then on the left side we will cancel sine of A, and on the right side we will cancel sine of B. And what we have now is B over sine of B equals A over sine of A. Next, we will draw another perpendicular from vertex B to the opposite side. Then this point will be point E and the height h sub 2. And now we have two more right triangles, ABE and CBE. In the triangle ABE, we will write that sine of angle A equals the opposite side h sub 2 divided by hypotenuse C. So sine of angle A equals h sub 2 divided by C. Then from here, h sub 2 equals C sine of angle A. Now, in the triangle CBE, sine of angle C equals h sub 2 divided by A. So we will write that sine of angle C equals h sub 2 divided by A. Then h sub 2 equals A sine of angle C. And now, because both these expressions represent h sub 2, we can make them equal. We will write that c sine of angle A equals A sine of angle C. Next, we will divide both sides by sine of A sine of C. Then on the left side, sine of A will cancel, and on the right side, sine of C will cancel. And now we will have C over sine of C equals A over sine of A. And now if we combine these two together, then we will have the law of sines. And that will be A over sine of A equals B over sine of B equals C over sine of C. So this was the first proof, and now let's see the second proof. For this, we will use the formula for the area of a triangle given two sides and the included angle. For example, if in this triangle we are given two sides A and B and the angle C, then the area is 1/2 AB sine of angle C. If we are given the sides B and C and angle A, then the area is 1/2 times BC times sine of angle A. And if we are given the sides A and C and the angle B, then the area will be 1/2 AC sine of angle B. Now, once these expressions represent the same area, we can make them equal. So we will write that 1/2 AB sine of C equals 1/2 BC sine of A equals 1/2 AC sine of B. Then if we multiply each expression by 2, we will have that AB sine of C equals BC sine of A equals AC sine of B. In the next step, we will divide each expression by ABC. Then to the left we will cancel AB, in the middle we will cancel BC, and to the right AC. And now we have sine of C over C equals sine of A over A equals sine of B over B. And this is the law of sines. If you found this video useful, please click the like button and subscribe to the channel. Thank you for watching.